see the types of C arrays. We have already become familiar with one-dimensional arrays. There are also multi-dimensional arrays. They can be two-dimensional, three-dimensional, four-dimensional, and so on. Now, multi-dimensional arrays are declared by providing more than one set of square brackets after the variable name in the declaration statement. For example, this is the general syntax of a multi-dimensional array. You first mention the data type, then you give the array a name, and then within square brackets you mention the size of each tuple. For example, if we are declaring a three-dimensional array of integer type, you need to mention int 3dim 5, 10, 4. 5, 10, 4 are the respective sizes of the tuples. You can visualize that as a cuboid which has the length, breadth and width as 5, 10 and 4. You can look of it at that in that way. It becomes simpler then. Now, two-dimensional arrays are more frequently used and we need to become familiar with that. For two-dimensional arrays, the first dimension is commonly considered to be the number of rows and the second the number of columns. This is the standard convention used. Two-dimensional arrays are considered by C or C++ to be an array of single-dimensional arrays. It is considered to be a collection of 1D arrays. For example, in numbers 5, 6. Then here the 5 is the size of the rows, number of rows, 6 is the number of columns. It would actually refer to a collection of 5 single-dimensional arrays where each array possesses 6 elements each. By extension, integer 12, 5, 6. Suppose this is another three-dimensional array, then it would refer to an array of 12 elements each, of which is a two-dimensional array. So this three-dimensional array will possess 12 paths, each of which is a two-dimensional array with number of rows as 5 and number of columns as 6. Now, another way of looking at this is that C stores two-dimensional arrays by rows, with all the elements of a row being stored together as a single unit. You can visualize that a two-dimensional array is actually a collection of several rows, and each row is a collection of n number of data elements each. You can also look up a two-dimensional array in that way. Suppose the 2D arrays in numbers 5, 6, then it is actually a collection of 5 rows, each of which has 6 elements each of which is a collection of 6 elements each. Now, how do we declare a 2D array? The simplest form of multidimensional array is the two-dimensional array. A two-dimensional array is naturally a list of a collection of 1D arrays. Now, to declare a two-dimensional array of size x and y, where x is the number of rows and y the number of columns, the syntax would be type, the data type, array name, the name of the 2D array, x and y within square brackets each, where type is the any valid C data type, array name will be a valid C identifier name, and x and y would be the sizes of rows and columns each. If you look of it as a table, the memory representation would be this way. For example, the first element is a of 0, 0. In this case, the index of first row is 0. The index of first column is 0. So, the first element is a of 0, 0. If you look at the next element, the row still remains the same. It's the first row itself, but we have progressed one column further. So, the row value remains same and the column index becomes 1. So, the element now is a of 0, 1. If you traverse the 2D array that way, the last element would be a of 2, 3. As there are 3 rows, 4 columns, the row index would be 1 less each. So, it will be a of 2, 3. 2 is the index value for the last row and 3 is the index value for the last column. Nextly, we look at initializing a 2D array. A one-dimensional arrays do not require the dimension to be given if the array is to be completely initialized. By analogy, multidimensional arrays also do not require the first dimension to be given if the array is to be completely initialized. All all dimensions after the first must be given in any case. Now if you correlate with the 1D array, if you were putting the values during initialization, if you are mentioning the values of each element during initialization, then you may not mention its size. The compiler automatically allocates that much of memory size for the array. Similarly, in 2D array, you can skip the first size within the brackets, but you have to mention the next size. So you can ignore the row size, but you must mention the column size. Otherwise, it would create problems. Now, this is an example of initializing a 2D array. Here, int A34. Each row has been initialized separately. It is actually a better programming practice to enclose each row within separate curly braces so that the program becomes more readable. This is required if any row other than the last is to be partially initialized. When subsets of braces are used, the last item within braces is not followed by a comma, but the subsets are themselves separated by comma. So it becomes clear that which row has to possess which data elements, which values given by the user. So in this case, each row has been allocated separately, and the rows are again further separated by commas, and that way the 2D memory allocation is done. The nested braces, which indicate the intended row, are optional. You can ignore them. If you ignore them, then the initialization will look somewhat this way, int A34, and all the values are given continuously separated by commas. But it is a bit confusing, and also it's not a viable option if you want to partially initialize the array. So it's a better programming practice if you separate the rows by using a subset of curly braces. So nextly, this example will access 2D array elements and make your concept a bit more clear. You include the header files as required, then you begin the main function, and then you declare a 2D array. Here it's declared of size 5 and 2, and each of the rows are initialized separately, so it looks even more clearer and you can visualize the array in your mind. And then integers ing and require, but in this case 2 for loops are used simultaneously in order for accessing the data elements. First you begin the for while loop for accessing the rows. The second for loop is used for accessing the columns, and then only the printf statement is executed. So if you see, for I is equal to 0, both j, the conditions for j are first executed. J is equal to 0, j is equal to 1. Since it cannot exceed 2, these two conditions are first executed, and then the control goes back to I again, and then it is executed for I is equal to 1. So in order to access a 2D array, you have to use 2 for loops. Then only you can access them, because it's a 2-dimensional array. It has both rows and columns, so you have to use 2 for loops. And then the value is printed. The value is given as a of I and j. I and j are the respectively indexes for that case, and that gives the required output. If you see, this is the output as given earlier. Whatever the values had been assigned row wise to the 2D array, that's the output given by the program. Nextly, we see how can arrays be passed as function arguments in C. You need to declare a formal parameter in one of the 3 ways. First one is using formal parameters as a pointer. For example, the function is present, and then in the parameter list, you need to declare that as a pointer. Suppose n star parameter, that would imply that it's a pointer. Next is using formal parameters as a sized array. For example, int parameter 10, it would imply the same thing. It is indicating an array. The third way is using formal parameters as an unsized array. You may or may not mention the size of the array in the parameter. If you don't know, you can leave it that way. You can leave it empty. You may not mention its size. So these are the 3 ways. Now recall that we had read 2 methods for passing ordinary data into functions. The first one was call by value, in which functions receive a copy and all changes are local. They do not reflect upon the actual variables. And the second one was pass by reference, in which whatever the operations were done inside the function, they were reflected upon the original variables. They were changed, they were altered. So if an individual element of an array is passed to a function, it is passed according to its data type. So if nums was declared as a 1D array of integers, then passing num_i will be the same as passing any integer variable of normal type, which is not an array element. Both the syntaxes are quite similar. Now when an entire array has to be passed to a function, it is passed by reference. That's a must. By default, it is passed by reference. You don't have to add an ampersand sign or something. By default, they are passed by reference. Because they are passed by reference, there is generally no need for a function to return an array, right? That's the basic logic behind it. Whatever the operations are done inside the function, it does affect the data in calling functions array. Now, nextly, we see that how the arrays are actually passed to a function. This is the program. Here, first in the main function, the double type array average is declared, which this program actually calculates the average of the input values. So average can be any integer or maybe floating value, you don't know, so you declare it as double, and then an array of size 5 is declared. Now see, when the function getAverage is called, the array is passed very normally, but inside the array, inside the function, whatever the changes are actually done upon the array, they reflect upon. The sum is calculated and then the average is given as sum by size. That's the general formula for any average or any mean. So this is how an array can be passed to a function. Inside the parameter list, it is declared as an unsized array and the size is passed separately. You can pass the size separately and then the average is calculated and the average is returned. This is how the output is given. Whatever the inputs are given, the average value is calculated and then returned back. So this is how arrays can be passed to functions. Now how do we return arrays from a function to C? Now there are basically 3 ways, but since you cannot return an entire array as an argument to a function, you return a pointer to an array by specifying the array's name without any index. The first method is using dynamically allocated array. You can use malloc function. First of all, you declare int star p using malloc function and of the size of the array, and then you can return so. Nextly, you can also use static array. This is the general syntax for declaring a static array. And lastly, you can use struct array. In that case, a structure of arrays is declared and then you can mention the function as struct array getArray. So there are 3 ways of returning array to a function. First is using dynamically allocated array, second is using static array, and third is using structures. Now the next is pointer to an array. Now it is mostly likely that you would not understand this section until you are thorough through this thing called pointers. Assuming you have some understanding of pointers in C, let us go ahead. An array name is a constant pointer to the first element of the array. The array name actually gives the address of the first element present in the array, the base address. For example, double balance 50. Then balance is a pointer to and balance of 0, and indicates the address of the first element here. Balance 0 is the first element and indicates the address. The ampersand sign indicates the address. So the array name actually points to the first element of the array. So the following fragment actually assigns P the address of the first element of ln. Suppose you declare a pointer P of double type, then that will actually get the value of the address of the first address element in the array. Now you can use array names as constant pointers and vice versa. Therefore, suppose you need to access any element of the array balance, then you can also write balance of 4 within square brackets as balance plus 4, and the star value, the asterisk sign, gives the value of the pointer. In this way you can also access the data elements. The next example will make it quite clear. This is the program to access the data elements of an array by using the pointer indexes, not the standard subscript notation. You use pointers to access each element of the array. The usual prototype is same, but if you look at the printf statements, then there the value of the array element, each array element, is mentioned as within round brackets balance plus I, and the asterisk sign gives the value. That is how you print the value of a pointer. If you become familiar with the concept of pointers, it would have become much more easier. So this is how you can also access the elements of an array using pointers. This is the output you will obtain. It's the same as obtaining using standard subscript notation. Nextly, let us look at an example of a program in which an array is reversed. There are many programs which you can do with arrays. You can reverse it, you can shift it, you can left shift, right shift, you can search an element, you can do many more things. So let us look at a basic example of reversing an array. This is the function fragment. You declare a temporary integer. Remember the syntax of swapping two variables. You use it do it by using 3 variables, 2 the variables which need to be swapped, and third one is a temporary. So you begin the loop which specifies the condition start less than end. Let us look into it. First of all, you assign temp the value of array of start. The first element is assigned the value of temp. Then the array start is then assigned the value of ending variable, and the ending variable is then assigned the value of temp. In this case, the first and last variables are swapped in this case. Then you increment start and decrement end. So in that case, the control moves a bit closer. Next, the second element and the second last elements are swapped. In this way, the loop progresses unless and until start becomes less than end. Then the while loops end. This will reverse all the elements of the given array. This is the main function which calls the reverse function, and the arrays are first of all declared and then they are passed. The size of the array is given by size of arr by size of arr0. What is arr0? Any element. You can take arr of 1 or arr of 2, all have the same size. That is how the size of an array is calculated. The total size divided by the size of each element. It's a basic formula. Then reverse array function is called, and then it returns all the values, and then the values are printed. So this is the syntax of reversing an array. If the array is given as 1, 2, 3, 4, 5, 6, the reversed array would be 6, 5, 4, 3, 2, 1. So this is how you reverse an array. The functions are printed by variables are printed by calling another function which is print array. The array is again passed as a parameter, they printed, and that is how the reverse function is executed. Now let us see how a binary search function is performed. The linear search is efficient. It's the usual way of searching a function, but binary search is even more efficient. In a binary search method, I'll just give the algorithm. You can work the program later on. You need to search a sorted array. I repeat, the array is already sorted. The elements are in ascending or descending order. You divide repeatedly the search interval in half. So the number of elements you need to access in each time becomes lesser and lesser, that is why the binary search is more efficient than the linear search. So you begin with an interval covering the whole array. And if the value of the search key is less than the item in the middle of the interval, the middle element, then you narrow the interval into half. If it is in ascending order, the middle element is even lesser. Then you can move on to the next half. Otherwise, you can narrow it to the upper half or the lower half as required, and repeatedly check until the value is found or the interval is empty. So the intervals get narrowed down again and again and again. The elements that are needed to be searched become lesser, and hence the program is compiled even faster. Now let us look into string arrays. Now string similarly is a sequence of characters that is treated as a single data item and terminated by null character. It is similar to a character array, but in a string the terminating character is null. That's the only valid difference. That's the basic difference between a character array and a string. C programming language does not support the keyword strings. It is not a data type. So you have to declare it as a character data type. So it is basically a one-dimensional array of characters. This is how a string is represented in memory. The last character, as you can see, is the null character. A separate storage location is assigned for that also. Now, how do you declare strings? To declare strings, you need to give its data type, which is naturally character. Then you need to give it a name and then the size. It's similar to declaring any integer array or any floating type array. In order to initialize the string, you need to give the value of the string within double quotes. In this case, you can also use curly braces, but in that case, you have to give each character within single quotes separated by commas. In each of the 4 given cases, the string will be initialized with the same value she coders, but there are 4 ways of doing it. You may or may not mention the size of the string in this case also. This is an example of execution of a string. First of all, a string character array is declared, then it is scanned, but in this case the symbol used is %s, which is for string, and then it is printed. It's quite simple. Now lastly, let us look at a program of multiplying 2D arrays. How do you multiply 2 matrices? You must be knowing the general formula, how to multiply 2 arrays, 2 matrices. This is executed in programming as follows. First of all, you input all the elements. You use 2 loops and you have to execute both the loops 2 times so that you input elements for both the matrices. Then nextly, this is the multiply matrices is the function which actually multiplies the matrices. Again, you use 2 loops, and then the multiplying concept is result of ij is actually the ik of first matrix multiplied by the k of j. That's the general formula. If you execute it, take an example and do it, you will get how the algorithm is followed. You first multiply each specific element and add up them, and that's the first element of the resulting matrix. So this is how that can be executed using a computer program. This is the main function from where all the functions are called of scanning the elements of the matrices, of multiplying the matrices, and lastly displaying the matrices. And that would finally give the output as given. Suppose the 2 matrices are inputted as follows, the output would be this much. The general formula of multiplying 2 matrices is followed, and this is how a simple program in 2D arrays is also implemented. So I would like to end my presentation with this. I hope you liked this video. Thanks a lot for your patience and watching this. Thanks.